Welcome to this lesson on temperature. Temperature questions on the LANTITE often involve reading thermometers, calculating changes over time, finding differences between two temperatures, and working with negative numbers. These questions are usually set in real-world contexts like weather forecasts, science experiments, or cooking. Let's build your confidence with all of these skills. Here is our plan for this lesson. We will start by reading temperatures on different scales, then move on to calculating temperature changes, both increases and decreases. We will spend time on finding differences between temperatures, especially when negative numbers are involved. Finally, we will tackle LANTITE-style word problems that combine these skills. Temperature is often tested alongside negative numbers, so make sure you are comfortable with both. In Australia, we measure temperature in degrees Celsius. The key reference points are 0 degrees is where water freezes, 100 degrees is where water boils, 37 degrees is normal body temperature, and a comfortable room temperature is around 20 to 25 degrees. When reading a thermometer on the LANTITE, always start by identifying the scale divisions. Count how many small marks sit between two labeled numbers. If there are 5 marks between 0 and 10, each mark represents 2 degrees. If there are 10 marks, each represents 1 degree. Getting the scale right is essential. Let's start with temperature changes. Part A, a rise. The morning temperature is 14 degrees and it rises by 9 degrees. 14 plus 9 equals 23 degrees. Part B, a fall. The daytime temperature is 22 degrees and it falls by 15. 22 minus 15 equals 7 degrees. Part C, falling below 0. The evening temperature is 3 degrees and it drops by 8. 3 minus 8 equals negative 5 degrees. This is where negative numbers come in. When the drop is greater than the starting temperature, we cross 0 and go into negative territory. Finding the difference between temperatures is straightforward when both are positive. You just subtract. But when one is negative, many students get confused. The easiest way is to use a number line. Think about the distance from -6 to 14. You travel 6 degrees to get from -6 up to 0, then another 14 degrees from 0 to 14. The total distance is 6 plus 14 equals 20 degrees. The rule is simple. When temperatures are on opposite sides of 0, add the absolute values. Ignore the negative sign and add. Here is a typical LANTITE data table. We have minimum and maximum temperatures for 3 cities. Part A, the range in Sydney. Both temperatures are positive, so simply subtract. 24 minus 12 equals 12 degrees. B, the range in Canberra. The minimum is -3, and the maximum is 11. Since they are on opposite sides of 0, we add the absolute values. 3 plus 11 equals 14 degrees. Part C, the difference between Canberra's minimum of -3 and Sydney's minimum of 12. Again, opposite sides of 0, so 3 plus 12 equals 15 degrees. Always check whether you are crossing 0. This multi-step problem is set in a classroom science context, which is common on the LANTITE. Water starts at 18 degrees, rises by 64 degrees, then drops by 35 degrees. After heating, 18 plus 64 equals 82 degrees. After cooling, 82 minus 35 equals 47 degrees. The final temperature is 47 degrees Celsius. Take each step one at a time and be careful with addition and subtraction. Here is a problem that goes below 0 twice. The temperature at midnight is -8 degrees. By 9 a.m. it rises by 13 degrees. -8 plus 13 equals 5 degrees. Then it drops by 17 degrees. 5 minus 17 equals -12 degrees. The overall change from the first midnight to the second midnight is -12 minus -8. Subtracting a negative means adding, so -12 plus 8 equals -4. The temperature dropped by 4 degrees overall. Practice these negative number calculations until they feel natural. Here are the most common temperature mistakes. First, subtracting a negative incorrectly. 5 minus negative 3 equals 5 plus 3, which is 8, not 2. Remember, subtracting a negative is the same as adding. Second, getting differences wrong when crossing 0. The difference between negative 4 and 6 is 10 degrees, not 2. You must add the absolute values when crossing 0. Third, misreading the thermometer scale. Always check what each small division represents before reading. And fourth, confusing rise by with rise to. These are very different instructions. Rises by 10 means add 10 to the current temperature, while rises to 10 means the new temperature is 10 degrees. Here is a graph reading problem, which is a common LANTITE format. The graph shows classroom temperature throughout a school day. Question 1 asks for the highest temperature and when it occurred. Reading the graph, the peak is 26 degrees at 2 p.m. Question 2 asks for the temperature range, the highest minus the lowest. 26 minus 16 equals 10 degrees. Question 3 asks between which two consecutive readings the temperature increased the most. From 8 a.m. to 10 a.m., the temperature went from 16 to 22, an increase of 6 degrees. That is the largest jump between any two consecutive readings. Now it is your turn. Pause the video and try these 5 problems. Problem 1. The temperature is 8 degrees and drops by 12 degrees. What is the new temperature? Problem 2. What is the difference between negative 7 degrees and 15 degrees? Problem 3. Water is at negative 2 degrees. It is heated until it reaches 68 degrees. By how many degrees was it heated? Problem 4. The minimum temperature is negative 4 degrees and the maximum is 19 degrees. What is the range? Problem 5. The temperature falls from 5 degrees to negative 9 degrees. How many degrees did it fall? Check your answers on screen. Let's recap the key points. Australia uses degrees Celsius. Know the key reference point 0 for freezing, 37 for body temperature, and 100 for boiling. A temperature rise means add, a fall means subtract. When finding differences across 0, add the absolute values. Subtracting a negative is the same as adding. And watch out for the difference between rise by and rise to. My top LANTITE tip for temperature questions is to draw a quick number line on your working paper. It makes negative temperature calculations much easier to visualize. Good luck!